Now let's take what we discovered from the warm-up to fill in our note page for today. So the top of the front page, it says the mid-segments of triangles. So in the shaded box, it starts by saying that JL is congruent to JM, and if we have segment KL congruent to segment KN, then what can we conclude in these two triangles? Well, the first thing we discovered was that given J is a midpoint of LM and K is a midpoint of LN, that JK is parallel to AM, or MN. We can also conclude, again, something about the length. We discovered that the length of segment JK was half the length of segment MN. And then again, we can write it without the 1/2 by saying that if I double segment JK, or the length of segment JK, that's equal to the length of MN. So within the first picture, it asks us in example 1 to find the value of X and Y. Well, again, given that this is a midpoint of that side, this is a midpoint of that side, I have a mid-segment, which is parallel to the opposite side. Therefore, Y is equal to 54 because they are corresponding angles given two parallel lines. And then we're going to find the value of X. So what I'm going to do is copy this triangle over here much larger. So here's X, 54, and then this angle is going to be 78 because it's also a corresponding angle given two parallel lines in a transversal. So using the angle sum of a triangle, I've got X plus 54 plus 78 is equal to 180 degrees. Solving for X, combining like terms, we have 132 degrees on the left. Subtract 132 from 180, we get X is equal to 48 degrees. Number 2, find the value of X, and X is in an expression representing the length of the segment of a triangle. So again, you can set it up as 12 is equivalent to 1/2 of 2x plus 4, or you can set it up as 2 times 12 is equivalent to 2x plus 4. Now, since the one expression is even, the longer segment, it's very easy to take 1/2. You can still take 1/2 of other segments, you just may be working with decimals. So I end up with 12 is equal to x plus 2. Subtract the 2, and we get 10 equal to x. In solving this one, I have 24 is equal to 2x plus 4. Subtract the 4, we've got 20. Divide by 2, and x is 10. And then the last one on the page. Go ahead and read that to yourself. So begin by drawing the equilateral triangle. Again, all sides the same. Each side is 10. And then I'm going to draw a second triangle which connects the midpoints of each of the sides of the triangle. So I'm going to go ahead and draw the midpoints first, where I think those are, and then I'm going to sketch the triangle. Now, this segment here is a mid-segment of this triangle, which is half the length of the side that's opposite, which is 5. Again, this is also, again, there are 3 mid-segments in a triangle. Here's another mid-segment, which is parallel to this side, so its length is half, and then so on with the third. So the perimeter of the second triangle that was formed by connecting the midpoints is 3 times 5, or 15 inches. All right, and moving to the back of the sheet, we're going to be taking a look at the mid-segments of trapezoids. I want you to make the note at the top of the page that mid-segments of trapezoids are also called medians. And I believe on your classwork assignment, some of the questions from Regents exams that I've taken have the term median rather than mid-segment, but it's referred to as both the median or the mid-segment of a trapezoid. So again, given in the gray box there, it says if segment ED is congruent to segment EA and segment FB is congruent to segment FC. So just again stating that E is the midpoint of AD and F is the midpoint of UC. If they're both midpoints of, again, the two non-parallel sides, then I know that EF is parallel to DC and it's also parallel to AB. The other property that we discovered is that its length is equal to half the sum of the bases of the trapezoid. So the mid-segment is 1/2 AB plus CD, or we can say that 2 times EF is equal to AB plus CD. So let's look at example number 1. We have to find both the value of x and y, again, which are algebraic expressions, or within algebraic expressions that have to do with the angles. Again, given that we have a mid-segment, this is also parallel to both of the bases. So these two angles here, this one and this one, are corresponding angles, and then these two on this side are same side interior angles, so they are supplementary. So the first equation to solve for y is going to be 4y minus 17 is equivalent to y plus 31. So to solve for y, I end up with 3y equivalent to 48. Divide by 3, and y is 16. Again, on the other side, these two angles here are supplementary, so I'm going to end up with the sum of 9z minus 21 plus 12z plus 37 is equivalent to 180 degrees. So now let's solve for z. Combine like terms, we end up with 21z plus 16 is equivalent to 180. Subtract 16, and 21z is equivalent to 164. And then divide by 21, and z is equal to 164 over 21. And we're going to leave that improper. Number 5 says, in the diagram below of trapezoid RSUT, RS is parallel to TU, X is a midpoint of RT, and V is the midpoint of SU. So it is a mid-segment. If RS, the length of RS is 30, and the length of XV is 44, what is the length of TU? So I'm going to call that X. Again, you can set it up as to 44, the mid-segment or median is half the sum of the bases, or you can say that twice the median is equal to the sum of the bases. So I've got 88 is equal to x plus 30, subtract 30, and 58 is equivalent to x. So that is answer choice 2. Last one. This time we're going to find the value of x. Again, same thing, given the mid-segment of a triangle, because I'm given the two segments of each of the legs, the non-parallel sides that make up those legs, or the segments that make up those legs are congruent, so therefore that's a midpoint. And this is a midpoint. So I'm going to again set it up as 2 times the median is equal to the sum of the bases. So 8x minus 18 is equivalent to 5x minus 3. Subtract the 5x, we end up with 3x. Add the 18, we end up with 15. Divide by 3, and x is 5. Now, on the classwork, the front of the classwork is a coordinate geometry proof. Okay, we proved the properties of the mid-segments within the construction and the warm-up. Now I'm going to have you prove the mid-segment of a triangle using coordinate geometry in the classwork.